Good day, and welcome to my presentation of how to hack WPA and WPA2, a look into Kali Linux and the tools of the trade. My name is Skulk Rist, I'm 26 years old, and I'm currently working as a cybersecurity engineer. Today we'll be looking a bit at Wi-Fi. Wi-Fi, we know, has been a growing phenomenon in society as we know it. We've seen great strides in technologies such as IoT, which primarily use Wi-Fi technologies or wireless technologies to connect the devices to the internet. We've also seen great strides in PAN technology, where an individual can connect all of his devices to a single network where they can communicate with each other. This is an example of this would be connecting your tablet to your smartwatch and your smartwatch to your computer and vice versa, and this will give you that ability so that all your devices communicate together. We've also seen that many fast food restaurants and restaurants alike are placing in Wi-Fi into their establishments to allow their patrons to surf the internet as they dine. Also, we know that Wi-Fi is prevalent in work and home environments. So the problem with this is that these technologies create vulnerabilities. For an example, you are sitting lavishly at a restaurant enjoying your meal and you have your phone connected to the Wi-Fi. Whilst you are eating, you are not paying attention to your phone, and attackers now have the ability to get into your device or spoof all the information that your device is sending to the AP. My demonstration and presentation today is to showcase such an attack and to show how easy it is to implement these attacks with the certain tools available to us. The advantages of Wi-Fi is that there is no physical mediums, cutting costs of implementing internet into a company by more than half. This also decreases the manpower that is required for the installation and the maintenance of the network, as there is less network connection points and less cables to worry about. These aspects create multiple points of failure in an environment, and as such creates a hard time to fix and maintain these networks. We also see a reduction in problematic areas such as natural disasters, as the Wi-Fi has no ability of transmitting the electrical surge to another device. The damage will then be stopped and located at the AP itself. But some disadvantages with Wi-Fi is that all information is transmitted over the electromagnetic spectrum. This gives the ability to any individual that is sitting within range and is equipped with a device that has a network interface controller that has Wi-Fi capabilities to intercept and see this information. There's also no true form of mutual authentication, which states that any device connecting to an AP has no way of knowing that the AP is the AP they are trying to connect to, and vice versa. The access point then will never know if the device that is trying to connect to it is the actual device that it says it is. This type of vulnerability is only prevalent in home networks, as there is no ePOL authentication. These Wi-Fi technologies and wireless technologies are susceptible to many forms of exploitation and attack. The main focus of this presentation and demonstration is to showcase the three different attack vectors that are most prevalent in these Wi-Fi technologies. The one is a pixie dust attack that will focus on the WPS setting on routers and APs, a dictionary attack, and the man in the middle attack. The task is to execute a WPA or WPA2 attack. The main focus is to target these three attack vectors. The main attack vector I will be focusing on is weak passwords. These are passwords that do not conform to current password standards and is very susceptible to attack and crack. The secondary attack vector is the WPS that was mentioned, and the WPS setting on routers and APs has the ability of bypassing all the encryption with the use of a 8-digit PIN code. The tertiary attack vector is spoofing. So the tertiary attack is to demonstrate how all of the information gathered by the two previous attack vectors can be used by an individual to gather information and use that information to their advantage. The tools I'll be using to implement this attack will be a Raspberry Pi 4 that's outfitted with Kali Linux, and I'll be using Aircrack, Ettercap, and Wireshark. But now it is time to head over to the Kali Linux to showcase an attack. So here is the Linux platform where I will demonstrate how to hack a WPA or WPA2 encrypted Wi-Fi router. Here I have created a file that has all the resources that we require to perform the attack. We will also need 2 instances of terminal. So first we will demonstrate the brute force attack. For this we will use Aircrack. First we will clear out all of the connections that might interrupt this hack. We can see the network has disconnected, and we can now continue with our hack. From here we will start the monitoring mode of the LAN 0 interface. We can see it's already enabled, and we can now go ahead and start sniffing the network on the interface LAN 0 for any hosts and clients that might be on that interface at this moment. So we will give it a little while in order for all of the hosts and stations that are on the network to populate the list. We can see they are coming in one by one. We can see that there is the ESSIDs, the Adams Family 2, and the Adams Family and Myers of Misanthropy. And there we go. We can now see that most of the hosts and bastions have picked up on the scan. We can then end the scan to start initiating a more precise, in-depth scan of the AP itself. So we will specify the interface, and then we will specify the BSSID of the router we want to attack. And also specify the channel. This will give us that more precise look into the AP and what traffic and stations are connected to the AP itself on that specific channel. Now what we want to do is wait for one of the stations to do a re-authentication. But who has the time to wait around? So what we are going to do is now initiate a de-authentication request that will de-authenticate the AP, the target, from the AP, and then this target will then reinitiate and reconnect to the AP. Once it has reconnected, we will then have all of the information we need to devise all the master keys and the password itself. So once we've specified the interface, we can now go back to the monitor and then initiate the de-authentication request. We can see that the target has re-authenticated to the AP, and we can see that there is the EPOL and the PKMID that has picked up. But now we want to output this data into a file so that we can use that file in our brute force attempt with our word list or dictionary. So we're going to output the file to this location. We're going to initiate the scan and then reinitiate the de-authentication request. The data will then have been populated in the folder. Now we can cancel the scan as we don't require it anymore, and we can initiate the brute force attempt. We'll use aircrack ng and then specify the file path of the .cap file we want to analyze. After we've done that, we can give it the file name and then tell it which word list to run this file by. And there we have all of the information we need. We will then save all of this information into the results text file so that we can use it later. Sorry, I'll rather use mousepad. And we'll save the data. Now we can go ahead and try and reinitialize the network manager by disabling the monitor mode on LAN 0 mon, which was our interface we used for the monitoring. And then we can restart the network manager. More often than other times, this actually does not work, but a quick restart will give us that fresh new device that we need to continue our attack. And this concludes my demonstration on how to hack a WPA or WPA2 encrypted Wi-Fi. I hope you enjoyed the demonstration, and I hope the demonstration was insightful. I do also hope that this demonstration gave you a new light into how vulnerable the use of public Wi-Fi access points are, in the fact that any attacker or any person that does connect to this access point has the passphrase. Once you have the passphrase, it is very easy to get the master keys for all of the sessions across that AP. This will allow an attacker at a public access point to easily spoof and listen in on anyone's conversations. The main point I want to drive home today is the use of weak passwords. There are millions and millions of weak passwords that have already been catalogued in the dictionary files that you have seen today. These dictionary files, the bigger this dictionary file is, the more information it has and the more passwords it has. Once this application is used, any password can then be deciphered. It is just a matter of time. So to review the results at the end of the demonstration, we can see it is very easy to establish a brute force attack simulation on an access point. With the use of dictionaries, as I said, the bigger the dictionary, the better. It is also very easy for anyone to get their hands on these tools and access these tools and learn how to use these tools. It is not necessary for a person to be an IT expert to learn these tools and hack into companies. The big fact that was brought up with this demonstration and the research is that once you are in, you win. So once you do have the password, you can do whatever you like. It's not always easy to get the password, but once you have the password, you can access anything over that access point and as well decrypt the information that is sent, emphasizing that risk on public networks. So please do use complex passwords. The current standard for passwords is the 10.4 rule, which incorporates the use of a minimum of 10 characters that has at least one capital letter, one number, one small letter, and then one special character. The use of these complex passwords will ensure the safety of your communications, but always know that there is a risk involved in accessing public networks or any network for that matter, as it is connected to the internet and anyone can connect. Thank you and goodbye.